Welcome to this lesson on vectors and scalars. Today, we will explore their definitions, real-world applications, scientific visuals, and key examples. First, let's look at definitions. A scalar is a physical quantity that has magnitude or size only. In contrast, a vector is a quantity that has both magnitude and direction. What does magnitude actually mean? Magnitude answers how much or how big something is. It consists of a numerical value paired with a unit, like 5 kilograms or 60 miles per hour. Other common words used interchangeably with magnitude or size include amount, quantity, intensity, value, and extent. Here is how scalars and vectors are used in everyday fields. In video games, your player health and score are scalars because they are just single numbers. However, your character's position, velocity, and jump force are vectors because direction matters. In GPS navigation, the distance remaining, such as 10 kilometers, is a scalar, but driving 10 kilometers north is a vector. In weather forecasting, a temperature of 25 degrees Celsius is a scalar, while a wind velocity of 20 kilometers per hour southwest is a vector. Graphically, a scalar is represented simply as a standalone value with a unit, such as speed equals 60 miles per hour. A vector, on the other hand, is drawn on a coordinate system using an arrow starting from the origin. The length of the arrow represents its magnitude, while the angle theta relative to the axis defines its direction. Here are 10 key scalar examples to remember: mass, temperature, time, speed, distance, energy, volume, density, pressure, and electric charge. And here are 10 key vector examples: displacement, velocity, acceleration, force, weight, momentum, electric field, magnetic field, torque, and gravitational field. Finally, here are 3 essential concepts for exams. First, vector notation is written either with an arrow above the variable or in bold text. Second, addition rules differ. Scalars add standard algebraically, like 3 kilograms plus 4 kilograms equals 7 kilograms. Vectors depend on direction, using geometric rules like the triangle law of addition. Third, a negative vector indicates the exact same magnitude, but pointing in the completely opposite direction. Thanks for watching.